Welcome to part 3 of Getting Started with OpsWorks for Chef Automate. I'm Nick Rycar, and in this video we'll take a deep dive into configuration management and see how with Chef we can apply configurations consistently across all the systems we manage. Whether those systems are long-lived or deployed dynamically in services like Amazon Autoscaling, we can confirm that everything is performing as we expect in Chef Automate as we detect, correct, and automate everything we manage and begin our continuous automation journey. Let's get started.
In part 2, we saw an example of how we can detect issues using the compliance view in Chef Automate and correct those issues with Chef Run. When it comes to automating this process, we're going to need to do a little bit more. So let's start by finding a new problem to solve. Back in our reporting console, I can filter to minor controls, and let's take a look at this issue. Time synchronization. This one is validating the NTP and cronny packages. And if we take a look at the source, we can see another feature of InSpec. Here, there are two packages that could fulfill our requirement for time synchronization. This one is using the describe.1 syntax to validate that we have either NTP or cronny installed. Let's go ahead and give this a go and get NTP running on our systems as well. We can, of course, solve this issue the same way we did in part 2, using Chef Run to apply the resources that will install our package, and since the package exposes a new service, ensure that service starts as boot and is started presently. Again, we can use the package resource to install NTP, and a similar service resource to make sure its associated service is enabled and started. That said, we can also collect these resources into recipes, which allow us to execute ordered lists of resources so that we can take care of all of our steps in one go. These recipes can be similarly applied with Chef Run, but we'll also want to make sure that we're continuously applying these recipes, so that if anything is manually changed on these systems, Chef can converge them and bring them back into their desired state. To accomplish this, we're going to need to generate a cookbook, which is an artifact that collects our recipes and can be stored on a Chef server, like the one deployed into our OpsWorks for Chef Automate environment. To get things started, Chef Workstation provides the Chef CLI tool, which we can use to generate a new cookbook, OpsWorks Demo. Back in part 1, I downloaded my starter kit, which is going to be important in this part since it contains some pre-configured configuration files that will allow me to authenticate with my OpsWorks for Chef Automate server and upload my cookbooks. Before we can do that though, we need to create our cookbook, which we're going to do from the Cookbooks directory. From there, we can run chef generate cookbook OpsWorks demo. And this will create the skeleton of a cookbook with all of the pre-existing configuration files and metadata that we'll need to get up and running. When we run the chef generate cookbook command, it will create a number of directories and files. For now, we're just going to concern ourselves with the recipes directory, which will contain a default recipe which defines the OpsWorks Demo Cookbook's default behavior if no other recipes are specified. We can add to this the recipe we created earlier, so that our recipes directory will contain both a default.rb and a myrecipe.rb. Once this is done, our default recipe need only include that recipe. By including recipes in this way, we can alter the default behavior of our cookbooks as we add or remove recipes from them. Once we've generated our cookbook, have added our recipe to it, and have updated the default recipe with our include, we're nearly ready to upload this cookbook to our OpsWorks for Chef Automate server. Before we do, however, there's one last problem I'd like to solve. While this will take care of our configuration for the time being, it does nothing to ensure that configuration stays consistent going forward. For that, we'll need to make sure that Chef Client runs on a regular interval and can detect and correct any issues that might arise on our server. To accomplish this, we can make use of the Chef Supermarket, an online repository of open source cookbooks that you can use to get a head start on your automation. Here we'll be taking a look at the Chef Client Cookbook, a cookbook that is owned and maintained by Chef Software, and which can be used to set up continuous automation via regular Chef client runs. Cookbooks often contain attributes, which are variables that can be used to alter their behavior without having to edit any of their underlying code. For example, the Chef Client Cookbook contains attributes for interval and splay, which define how often our machines should check in, whereas splay adds in a random amount of seconds to that interval to ensure that as we add more servers, they don't all check in at exactly the same time. We can take advantage of this behavior by making use of Chef's Cookbook Dependencies feature. In our OpsWorks demo cookbook, there is a metadata.rb file. This file contains our cookbook name and version, but can also be updated to add a dependency on Chef Client. By adding this dependency, we can alter Chef Client's attributes by having our cookbook set its own default attributes for the interval and splay values. Here, I'm setting our cookbook to check in every 60 seconds with a splay of 15 seconds to make sure we get nice, speedy feedback in our demo. Once we've done that, we just need to update our default.rb recipe, which can be used to include recipes from dependent cookbooks as well as those defined within our cookbook. Here, we're adding the Chef Client config and default recipes to ensure our nodes are set up for automatic convergence. Now that our cookbook metadata has been updated with our dependency, our attributes have been updated with our default interval and splay values, and our default recipe has been updated to include the Chef Client Cookbook, we're ready to upload to our OpsWorks for Chef Automate server. To accomplish that, we're going to make use of another tool in Chef Workstation called Burks. First, we're going to navigate into our cookbook directory as seen here and run Burks install. This is going to install every dependency our cookbook needs, which will include Chef Client, as well as any cookbooks that Chef Client itself depends on, without us needing to define them explicitly in our metadata. Once that's complete, we can run Burks upload. Since we're within our starter kit, we already have a configuration file set up to allow us to upload to the Chef server. Once this is complete, we can now start making use of our new cookbook. Once our cookbook has been uploaded, we're ready to start the client bootstrapping process. Chef Workstation includes a tool called Knife, which we can use to add new nodes to our Automate server for configuration management. The Knife bootstrap command lets us pass it our host name or IP address, give that host a friendly name in Chef, give it a run list defined as a list of recipes we'd like to execute, and finally, the username and password or SSH key we'd like to use to connect. I'm also running with the -- sudo flag, which makes sure our commands are executed as an administrator. This will add our node to our OpsWorks for Chef Automate instance, as well as kick off the Chef Client process, which will take a number of steps to make sure it grabs all the information it needs for our node and applies the recipes we've specified in our run list. Once again, from somewhere within our starter kit directory, we'll run the Knife bootstrap command. This will configure our host with the Chef Client and run our recipe to ensure both that NTP is configured and that Chef Client is set up for a continuous run. Back in Chef Automate, we can review our node's configuration status in the Nodes tab. From here, we can click on our demo host node and see the full history of Chef Client runs. With each, we can filter resources by the total number that were evaluated, how many, if any, failed, and the remainder are successful or unchanged. Unchanged resources, like uninstalling Telnet, are resources that don't need to take any action because their desired state was already met, whereas successful resources shows us the actual changes Chef made, like making sure the NTP package is installed. We can confirm that this actually solved our issue by coming back into compliance, viewing that same node, and now we see in minor controls there are 6 rather than 7 issues, and NTP no longer shows up on the list. With the Knife bootstrap command, we're able to bootstrap new nodes wherever they live over SSH or WinRM. But one of the benefits to deploying into a cloud environment is being able to use tools to more dynamically provision our infrastructure, like AWS autoscaling. Thankfully, autoscaling integrates quite nicely with OpsWorks for Chef Automate, allowing us to set policies to auto-bootstrap auto-scaled nodes. This integration is outlined in detail in the OpsWorks for Chef Automated Getting Started guides. Here we can see all the steps required, starting with creating an IAM role with the appropriate permissions to associate new nodes with our OpsWorks environment. I've done this already in my environment, but you can do it in yours with this easy copy-pastable command that can be run from your terminal. From there, we're going to hop back into our starter kit to modify the included user data files. Back in my starter kit directory, I've opened up the whole directory in my text editor. Here we can see the full directory listing, including the cookbook I've worked on previously, the .chef directory, which contains the knife configuration file we've used to authenticate, as well as 2 user data scripts, one in PowerShell and one in Bash for Windows and Linux hosts, respectively. These scripts have been preceded with information specific to my Chef Automate server, and I haven't had to input this data myself. The only change I've made is to line 21, where the run list has been set to run the default recipe out of our OpsWorks demo cookbook. It's worth noting that it's functionally equivalent to write just recipe OpsWorks demo. As we saw previously, if no recipe is specified, the default recipe will be used. Before we can create an auto-scaling group, we first need a launch template, which defines the default configuration parameters for each instance launched within the group. From the EC2 dashboard, we can go to Launch Templates and Create Launch Template. We'll start by giving our launch template a name, defining the default AMI, instance type, and key pair to use, as well as which security groups to add to newly launched instances. From there, we can expand the Advanced Details tab to add our IAM instance profile, and I've seeded mine in, as well as the user data we've defined in our starter kit. From there, we can create our launch template and create an auto-scaling group within it. In the auto-scaling group wizard, I'll start by giving our auto-scaling group a name and a default subnet. From there, we can define our scaling properties. And right now, we're just going to keep this group at its initial size. Nothing else needs to be done at this point unless you'd like to add notifications or tags, and I'll just go ahead and create my auto-scaling group. Once our auto-scaling group finishes launching our nodes, they're automatically bootstrapped with the Chef client and show up in Chef Automate's Nodes view. Here I can confirm that our new node had all the same resources applied to it and has the same running state as the initial node we configured. However, we don't yet have any compliance data for this new node. If you'll recall from part 2, we created a new scan job where we connected to our first node directly over SSH. For services like auto-scaling, this isn't going to be a very feasible solution for us, as new nodes might be getting added or deleted at any time. We can counter this by using the Audit Cookbook, another supermarket-provided cookbook which will run compliance scans as part of our Chef client run. The only thing we'll need before updating our cookbook is the full name of our compliance profile. This can be easily copied out of the profile store under the identifier header via this button. From there, we can update our cookbook the same way we did for the Chef client. Here I've added a dependency on the Audit Cookbook and incremented my cookbook's version. I've added the Audit Cookbook to my included recipes, and as before, have left the recipe blank, which is equivalent to the default recipe. Finally, my attributes have been updated to tell the Audit Cookbook where to find our profiles, as well as which profiles to run. And here's where we paste the name we copied out of our Automate server. From here, once again, we'll upload our cookbook with Burks. From the starter kit directory, we navigate to Cookbooks, and then to our OpsWorks demo cookbook, do a Burks install, where we'll pull in all of our new dependencies from Audit. And finally, Burks upload, to upload our new cookbook to the Chef server. Because these nodes are configured to check in every minute, once I've uploaded my new cookbook, I don't need to take any further action. The next time each server checks in, they'll notice that their policy has been updated and take any action requested by the audit cookbook. That way, when we come into compliance, I can validate that my auto-scaled node shows up and run it through the same CIS evaluations as the first node we started with. In this same way, as the auto-scaling group adds and removes nodes, each will get bootstrapped and generate an audit every time their configuration gets updated, so that you can detect, correct, and automate issues consistently, no matter how many environments or systems you support.
That's it for part 3. To learn more about using IAM policy and auto-scaling groups with Chef Automate, check out Amazon's unattended bootstrapping documentation. And to refine your chef skills, be sure and cruise on over to Learn Chef Rally's continuous automation track. Finally, to see everything we've covered in this series in more detail, check out the joint webinar that Chef and AWS did, Automating Cloud Compliance and OpsWorks for Chef Automate. I've been Nick Rycar, and thank you for joining us.